Anyway, I'm recording. But I was expecting more people. Why? It seems that we should be more people in the class. We should be at least, let me see. One person is missing. So, okay. And another thing that is going to be cool is that our class is a little bit small, okay? Which is also, I guess, pretty good. So, Luis Miguel and Santiago, Oscar, you didn't take the class with us, do you?
Yeah, I took, I don't remember the name. I don't remember the name of the.
Audio programming.
Yeah.
But last semester with us?
I know. The third semester? Yeah, 5.
I see. Okay. Okay, so I'm going to ask you to leave your cameras on if you don't mind. That's really good for me because I can see your faces. And again, I can see that you're starting to get tired or things like that. So I really beg you to turn on your cameras. Okay. Okay, this class is called MIDI class. This class was created in 2006. The syllabus of your career is from 2006. So if you start to make some kind of addition or actually subtraction, you will realize that this syllabus was created pretty much, how much? 15 years ago? 15 years ago, okay? And many things have happened in the previous 15 years, okay? So because of that, we are going to try to update everything that is MIDI based to some more modern and actual context, okay? So we are not only going to be talking about MIDI, but we are also going to be talking about the new ways of sending and retrieving information over different protocols, okay? However, we do need to talk about MIDI. You probably use MIDI all the time, although you may or may not have the famous, let me find one of my cables because I have like 60 cables of MIDI cables. I pretty much, I don't think you don't have any. Give me 1 second, please. Okay, so I will introduce you to the antique and really old little crappy cable that is here. You know it? Do you still have some instrument with that? Do you work on your daily basis with something that has this connection?
I think we can see it, Professor.
What
I
do you
think
mean?
Your face.
Yeah.
Oh, but the cable. Can you see me?
No.
Your video.
Oh, I see. Would you saw my cable? Do you have instruments that use this instrument? That
No,
use...
and the camera froze again.
What about there? Can you see me? Oh, okay. So, do you have one of those cables at home? No, nobody? Anybody? No, at all? Aldo, Pablo, Oscar?
What type of cable?
A MIDI cable.
No.
No.
Sorry, what was the question?
If you have any device at home that uses a MIDI cable.
I have a MIDI controller, but not a MIDI cable.
I
I
know.
think I have one.
Okay. Yeah, because over the last maybe over the last 10 years, the protocol remains the same, but the connection will get updated to a USB cable, right? Which is basically universal serial bus. We will have to talk a little bit about the MIDI protocol because that is the essence of this class. And after that, we are going to start to jump directly into coding MIDI, which probably is more interesting than developing interfaces for the MIDI cable. However, creating MIDI interfaces in the 80s was something that it was really high. It was very, very, very attractive to do your own MIDI controller, right? If for some reason you need to build some electronic device that generates MIDI, that is also a very nice way of understanding the protocol, okay? So I'm pretty sure that you've been working with MIDI in some music production class, or maybe on Live, or maybe on Pro Tools, or maybe on Cubase or Reaper, or any of those programs has channels where you can record either audio or you can record MIDI. So if you have your MIDI control, you are actually connecting to the MIDI and sending information back and forth, and you are doing that kind of things. Is anybody here, or the question would be, has anybody here never worked with MIDI protocol ever? It's okay to say no. No? Pablo? So everybody has worked with MIDI in some extent. Yes? Juan Pedro? Juan Pedro?
Yes, I have.
Axel? Luis Miguel?
Yep.
Okay. So have you ever had to modify a MIDI message in some way? No? So we have some yes and we have some no. Okay, maybe then that's the level. Okay. So I'm gonna start to share my screen just for one second. Okay, I'm gonna tell a little bit of more story about this. In the 70s, actually, let me show you. Actually, I'm gonna show you my screen. What is the origin of the MIDI? Emerson, Lake, and Palmer? Let me show you some images of some rack of this kind of musicians. Let me see, or Rick Wakeman. Rick Wakeman. Okay, can you see this studio? Okay, this was the kind of setup that you need to do, that you need to have in the 80s, or in the 80s, okay? Because you have one instrument that produces one sound, one keyboard that produces another sound, one keyboard that produces other kind of sounds, one keyboard that produces another kind of sound, one keyboard. So can you imagine what does that mean in terms of music production, in terms of having a setup in the studio, or even more challenging to move into a tour with 20 keyboards? Okay, it was insane. It was really not necessary. So in 1990, 84, I think so, all these Japanese companies, especially all the people that was generating synthesizers, Korg, Yamaha, which another one that was big in that time, Roland, all of them sit in a chair, sit in a table in an office, and decide to create a protocol for communicating over musical instruments. Okay. One of the nicest things of this story is that the first connection between two digital devices of different brands was through MIDI. So in some way, you can say that it was through music that different companies could get and start to talk about sharing information, which is pretty nice in that sense. Okay, so they sit in a chair and they develop a protocol for sending not music, but sending data that represents music. Okay, they didn't have the bandwidth, the digital bandwidth for sending audio over internet or for sending huge amount of channels over the internet. So they were just concerned about sending a small queues of data that could send MIDI, okay? Which at the end becomes a really tricky and hard and sad problem. Because in order to achieve that, all this sample way of organizing music became the standard, and the sound quality get a little bit compromised because of that. So the open sound control was a direct fight against MIDI at the end of the 90s. We will talk also about OSC at the end of the semester, but at least we will be working with MIDI for 1 month. Okay, so they sit together and then decide to create what is this. Give me 1 second. This MIDI association, okay? And then decide to create, which is the MIDI specification, okay, of this. So have you ever studied the MIDI protocol? Have you ever studied what is inside the MIDI protocol? No, not at all. No, Oscar, no. Okay. Okay, so we have, so what have you changed with MIDI? The note, the volume, what else have you changed?
The attack.
Okay, the attack.
The instrument.
The instrument. Just that?
Pitch. We can modify a lot of things, no? Like
Yeah,
pitch, oscillators, amplifiers.
You are not you do not change the oscillators. Maybe you can
Oh.
change the sounds, but not the oscillator. So let's go a little bit to the protocol, and then we can go here to here, okay? And then we will go to the MIDI protocol, and then we will go to the document here, okay? And then this is the specification. You can go here, and this is what, if you start your own company and you start to create your own instruments, you will have to go and follow all of this specification if you want to be if you want to follow all of these instructions. So let me go first of all to MIDI protocol, to whatever. Okay, maybe we can find it here. Okay, this is the story. You can go through the story. You can go to the, let me go to the English. Okay, and you will start to hear all what we are talking about, the implications, the impact, the instrument control, and then the different compositions that you can do, and then the standard file, and all of these that you can go directly. But where I want to go, the original cable, okay? This original cable that uses 5 pins, in reality, they only use 3 pins, okay? Which were ground, voltage, and then signal input and signal output, okay? And then we can go directly to the specification. This was something that was really nice. Also, this is the diagram that requires to be inside any of these synthesizers at the beginning of the story. This was the cable, okay? It cannot be longer than 10 meters because the downhill of the voltage, you have the pins, and it has something that was pretty nice. It has an opto-isolator, okay? An opto-isolator means that you are not sending here current anymore. The current that coming here, it's converted into light, okay? And the light is recovered again into the voltage in the other device, okay? Why? Because in that way you guarantee that you don't break or you don't burn or you don't toast any of the synthesizers if you plug the output with the output or the input with the input, okay? And then at the end, it comes to a universal serial port that is here, okay? This diagram is so simple, it is so simple that you can, in the future, if you want to do it, you can Arduino MIDI. You can go here and then you can create, as you can see, build your own MIDI with an Arduino, okay? And actually here you have Arduino with this socket, okay? But it is as simple as that. And you will see here the piece of code that happens to be inside here. Let me go to the code, okay? Have you ever taken a class with electronics? Have you? I guess yes, right? Did you code the Arduino or what did you code? What did you, Fernanda?
Just drawing circuits and simulator, but nothing about coding.
Okay, but you create devices but you didn't solder with an iron in a plate. Why? Because it was in the pandemic or because of what?
Yes, because of that.
Oh, that's too sad. Okay, well, never mind. Okay, the important here that we have to understand is that at the very end of the story, we are creating a serial communication, okay, with a specific baud rate, okay, of 31,250, okay? That was part of the standard. What is the difference between a serial protocol and a parallel protocol, Aldo?
I can remember.
Try to infer just by the name of the words, by the meaning of the
Serial
words.
is one step after the other, and parallel is at the same time. I figure out that is that.
Exactly. So in the 80s, you also didn't live that period of time, but at the beginning of the standardized of computers, the printers, for example, any printer that you go and you buy an Office Max, well, there was no Office Max, but if you get a printer, okay, the kind of connection that it has, it was a huge, long array of pins, because in order to connect to a printer, you are using a parallel protocol. So imagine that you want to read a full book, for example, Don Quixote, okay? What is faster? Fernanda reading the book from the beginning to the end, or Axel reading even pages and Luis Miguel reading odd pages, okay? So what is faster? Who's gonna finish reading the book first? Fernanda reading the book from the beginning to the end, or Axel reading even pages and Luis Miguel odd pages, okay? At the same time, Axel and Luis Miguel are reading at the same time, okay? Or Fernanda reading. What is faster?
I think it would be reading the whole thing from beginning to end.
Faster?
Well, no, I don't know.
Omar?
Both people reading the book, one odd pages and one the other ones.
Well, the question has a jiribilla, as you say in Spanish. Because you should maybe ask something in order to answer this question.
Well, the Axel and Luis Miguel will be finishing before, but I don't think that they are going to have the full information about the book, because it's going to be very weird if you read one page, then forget about the next one, and then you start the other page missing one uh, type of information.
So
Yes, there will
exactly,
take more time on that.
the person that has to decodify the information that Axel and Luis Miguel are reading will need to have kind of a memory, as Ricardo is saying, a buffer in order to put something and then waiting to the page to end. And then it's a little bit, as a protocol, a little bit more complex, right? But there is also another important thing that you didn't ask that is very important in order to answer this question properly, which would be the speed in which Fernanda is reading and the speed in which Axel and Luis Miguel are reading, okay? So how can you make the information to go faster? Well, Fernanda reading 4 times faster than Axel and Luis Miguel, for example, right? And that is what it happened at the end of the story. It is very weird to find in this period of time any protocol that sends information in parallel, okay? Even the Ethernet is a serial communication. It's only one line of information. However, this information can become faster and faster and faster. Okay, so pretty much all the protocols nowadays are serial, which means one after the other, one after the other. Okay, and now how fast? Well, this is what is described here. Okay, how much information can you send per second? Okay. In this particular case, what you are actually doing, sending in the cable, are 2 lines of cable. Let me add 2 lines of cable. So, give me 1 second. You have ground. You have, no matter how many cables do you have, which in those cases were 5 pins, okay? But now they are being replaced. But in reality, you are sending 3 lines. 1 line of information that's going from this instrument to this instrument, okay? 1 line of the information that is coming to this, from there to here, okay? And 1 line of code that put both systems in ground, okay? Why? Because what you are sending here is voltage, probably 5 volts and 5 volts, okay? So as you well know from your electronic classes, what is voltage? What is voltage? Can you remember?
Well,
what
is the force in which the electrons are moved, right? Is the different potential that
Oh,
an electronic, well, electric or electronic devices has
oh, that's good, Omar. What you are saying is a different, what did you say? Differential what?
of potential. I mean,
Yes.
electronic potential.
Which, well, in Spanish sounds nicer, which is diferencia de potencial, right? But the concept of difference, in order to say that something is different, that means that you need a reference, right? You need a reference in order to say that something is above 5 steps, or maybe below 5 steps, okay? Or maybe above 10 steps, right? If you get a voltmeter and you measure the distance between this one and this one, what is the multimeter gonna tell you in terms of voltage?
5 volts.
5 volts, right? And between this one and this one?
10.
And between this one and this one?
15. Well, no, wait. Yeah, 15.
15 volts, okay? That means that everything is based on such a reference. You need to have a reference, okay? That's why when you want to communicate information between two electronic devices, first of all, you need to set up a reference to homogenize or to make the same reference. That's why in this cable, you are actually saying we are gonna share the ground. And then you have one line for sending, which in this case was output. Do you know Mijael from Tec de Monterrey, Ciudad de Mexico? The director of, no, Santa Fe. Have you seen his hand? His, how do you call this part of the body?
Wrist.
Have you seen his wrist?
Mhm.
No, he has a tattoo of the MIDI protocol. Tiki, 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 tiki. He has a tattoo of the pins. Okay, so he tattooed himself the input and output input, and then in the other hand, in the left hand, and then the right hand, he has the output. Pretty nice. So maybe he should be teaching this class because he's really into MIDI, right? But okay, so what we are saying is that you have the output here, and you have one that is sending the output here, and then you get the input here, and then you get the input of the other instrument here, okay? So what is exactly what you are sending? What is exactly what you are sending? The only thing that you are sending are voltage or zero voltage, voltage or no voltage, voltage or no voltage, voltage or not voltage, okay? However, you have to send it in a very specific amount of time, okay? You have to be sure that you are sending them all the time at a specific speed, because the person that is waiting, okay, is expecting to have that information. So imagine that I can send you voltage, no voltage, 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 no voltage, not voltage, voltage. Can you see that I create, if you see it on the oscilloscope? Have you ever worked with an oscilloscope, right? I guess yes. Yes, Estefania?
I think I did, but I'm not quite sure about it.
The oscilloscope is like the thing that you see in the movies when the poor guy is dying, and then in the hospital they are measuring the pulses of the heart, and then and the poor guy is gone. Okay, well, that is a way for representing the evolution over time of a voltage that is changing. Okay, so I'm pretty sure I need to know if you did that kind of experiments on some class in high school or at the beginning of the classes at the program. No, Estefania?
I think I have, but I don't have good memory, but I think I'm like maybe 98% that I have.
Okay, so I'm gonna start to send you information, which, by the way, who was the first person sending messages over the air? Who was the first person over the first community sending messages over the air in order to say something? Who were the first communities trying to say something to another community that was far away?
With pigeons and birds that carried messages.
Oh, no, oh, I see. No. I guess before that, I think, no, before that.
With how can I say señales de humo?
Exactly.
Smoke signals?
Smoke signals, okay? So pretty much the MIDI protocol is like smoke signals, okay? In some way it's the same, because what you are sending is sending a smoke, then you wait a little bit, then you're sending a smoke, and then you wait a little bit, and then you wait a little bit, and then you wait a little bit, and then you're sending a smoke, okay? Does that make sense? However, the person that is waiting should know the periodicity in which things are happening. Otherwise, the person is going to get extremely confused, right? This means that these are time-based protocols. Okay, now another protocol that is based on sending and not sending information in order to generate some message. Another protocol from a long time ago in which
The fax?
before the fax.
Morse code?
Exactly. Do, 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 do. What am I saying?
SOS.
Exactly. SOS, which is the international message for saying careful or emergency or help, right? And why do you know that this is an S? And why do you know that this is an O? And why do you know that this is an S? Because both persons should know the protocol on the fly, right? And you also need to understand that this is twice the size of this one, right? Pretty simple at the end, right? Another example of something that you need to know that you are dividing over time. The nice thing of this protocol is that you could send it over anything. You could send it over electricity, or you can send it over sound, or you can send it over light, like in the ships that they were sending messages through light, right? So based on that, if I have an electronic device where I can send voltage, this is time, okay? These are the moments in time in which I can send voltage or stop sending voltage, okay? And then imagine, again, it would be really hard. It would be extremely hard to measure the amount of voltage. It's way more simpler if you only send voltage or you stop sending voltage. You cannot send 0.5 volts or 1 volt or 3 volts. That's electronically very hard to measure. And because these cables are really long, okay, and then you start to have noise over the cables, it's more simple if you only say, I will send information or I will not send information. And then you have a threshold, okay? That is also important. You have a threshold, okay? This is the threshold in which you are assuming that you are sending information. So if you are trying to send information, but your battery is running out and you're running out of battery and you try to send it, but you do not reach that moment in time. And then you try to send it and you don't reach that moment in time. Even if you see in the oscilloscope that you are sending messages, it's probably that the analog to digital converter that is here is not going to be able to understand this as a 1. It's going to remain as a 0. And another problem that you have, if you have electrostatic in the air, because there is a lot of noise in the air, electronic noise, or maybe it's raining and then you have a thunder, and the thunder generates noise all the time, okay? And suddenly that noise exceeds something. This is gonna be understand as a 1 message, okay? That's why the threshold is very important in the context of the signal that you are sending, okay? But then one more time, okay? The nice thing of this is that I can send messages. Again, I'm gonna put time, or actually I'm gonna send you the message to you, okay? Can you hear my hand, right? Okay, please grab a piece of paper or whatever, because I'm gonna start to send or not sending information, and I want you to read it, okay? So here we go. I'm gonna start to send at 1, 2, and 3. Teet, 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 teet. Could you repeat me what I did? In terms of zeros and ones. Juan Pedro.
Well, basically, you could have represented what is sending voltage, but through the sound, right?
Yeah, but I was asking you to notate it because I need the specific sequence that I sent. Did you write it?
No, but yes, I agree with Fernanda.
Okay. Oh, Santiago, did you did it? Did you do it? Could you tell me the values, please?
I got confused and didn't write them all, but I got 1 0 1 1 1 0 1.
1 0 1 1 1 0 1, and I think it was 0 and 1. Am I correct? Okay.
Yes.
So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. So I just by random, I sent 9 bits of information. The people that took the class with me last semester, I think that at the beginning of the class, we saw this a little bit. Am I right? Pablo?
Yes, I think so.
Yes, or was in another class? I am starting to get confused. Ricardo, do you remember?
What? Sorry?
Did we saw all of these bits, bytes, and binary protocol on the class?
I don't think we did, but I remember seeing it on another session.
Another class in another course?
Yes.
Okay, so, well, how many values can I code or generate with 8 bits? How many different values can I send or can I describe with a set? Imagine that I didn't send this one, okay? Forget about this one.
60.
So as you can see, I have 1, 2, 3, 4, 5, 6, 7, and 8 different values that could be either 0 or could be either 1. This could be either 0 or 1. And then Fernanda is saying 60 or 16?
16.
Okay, 16. Well, no. Luis Gerardo.
256.
Who talked? Who talked? Juan Fernando?
No, I said 256.
256. Why do you say that? Did you know
Because we have 2 combinations, 1 and zeros, repeated 8 times. 2, bueno, cuando haces un 2, el exponente 8 es 256.
Sorry, I don't speak Spanish. Neither English. Okay, so yes, it's 2 to the 8. Why? Okay, let's go again, and then let me 7 and 8. How many different values can you send when you only have 1 bit of information?
2.
Which is 0 or 1, right? How many when you have two bits?
4.
0 0 0 1 1 0 and 1 1, right? How many when you have 3?
8.
0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Okay, which I guess is 1, 2, 3, 4, 5, 6, 7, and 8. Okay. And so on. I'm not gonna do the one with 4 because with one with 4 is 16. Okay, so you have, when you have 2, you have, when you have 1, you have 2 options. When you have 2, you have 4 options. When you have 3, you have 8 options. When you have 4, you have 16 options. When you have 5, you have 32 options. When you have 6, you have 64 options. When you have 7, you have 128. When you have 8, you have 250. When you have 9, you have 200, 15 and 12. When you have 10, you have 24. When you have 11, you have 20 and 48. And when you have 12, you have, and so on. Okay. Why do we know these numbers? So each time that you see these kind of numbers in computer science, something is fishy, or actually not fishy, the other way is logic, okay? It's logic because you are talking about a specific amount of bits that you have, okay? Now, 8 of these ones, 1, 2, 3, 4, 5, 6, 7, 8 of these ones, 8 bits, it's equal to 1 byte. Okay, so you should have this in mind. Why do you have everything parsed in 8 bits? Because it's very well organized geometrically speaking. So it sounds logic that everything starts to be organized in terms of bytes. Okay, so when you are writing an HTML code and you decide to select the color, for example, the RGB colors that you will find in any program, you will see that you have 256 possibilities of red, and then 256 possibilities of green, and 250. Why? Because you are using 1 byte, right? Okay, for setting up the different colors that you have in one channel, which means that at the end you have 3 bytes for describing the color in 1 pixel. Does that make sense? Okay. And why are we talking about all of this? Well, we are talking about all of this because the MIDI protocol is made of one MIDI message, okay? One MIDI message is made of 2 bytes, which means that it's made of 16 bits, okay? So in order to send just one little message, like saying, play middle C at volume, at maximum volume on channel, whatever, you need to have 2 of these ones. Okay, so, and that if we were in presential classes, I would get an oscilloscope and I would show you how the information is sent, because it's kind of demystifying the electricity when you start to see it over time. You can see a message going through the cables, okay? And that clarifies a lot of the things. But for now, you will have to trust me that in that cable, you are actually sending smoke signals at a really fast speed, saying yes, no, yes, yes, no, yes, no, no, yes, no, yes, no, 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 yes, and no, for example. And this information will encompass 1 MIDI data, okay? Now, let's study the protocol in order to understand what are we talking about. So I will go to here, and then we will go to see the MIDI protocol. Oh. Okay. And then here we have it. Okay. These are the MIDI messages, okay, which we have to study. Let's see this one, okay, which is here. Now, do we understand this crappy message, or is kind of, I don't understand anything? You will say, well, if you would understand that, you really need to take this class. Okay, let's see it. Okay, where was it? Okay, it's here. MIDI messages. Let's study this page a little bit. A MIDI message is made of an 8-bit status byte. Okay, that means that first of all, we have a 8 bits, which would say 1 byte, right? Of the status byte, okay, which is generally followed by 1 or 2 data types. Oh, interesting. There are a number of different types of MIDI messages. When I was asking you, what can you send? You can send notes, you can change the bank of the sounds, you can send parameters that affect all the channel, and so on. By the way, have you ever worked with MIDI channels? Have you ever worked with MIDI channels? Yes, everybody is familiar with that notion. Santiago, you say no, okay, it's fine, okay. Part of the protocol, when they decide to do this, they say, okay, but in one cable, we should be able to send information to many different devices, okay? So you can chain them theoretically with one cable. So in order to have, for example, one keyboard here, okay? One keyboard. Over the pass of the time, when they set up the instrument, then you didn't need to carry 20 synthesizers to the tour, right? You just need one MIDI controller and then a bunch of what it was called, for example, a MIDI module. Like these ones, let me see. No, these are too new. Let me show you. Wow, expensive. Like like this one, okay. This was the substitution, the modification of a MIDI keyboard. You don't need the keys, okay. You just need the machine, okay, the machine that generates the sound. Does that make sense? So if you just need the machines for making sounds, okay, you could have in 1 second, you could have one keyboard and only a bunch of racks. This was the famous Pro Tools, no, what was the name of a very famous Proteus? I think it was Proteus. Proteus was famous for the piano sounds, okay? For example, Korg was famous for the brass sounds, okay? Roland has a very nice organ sounds, for example, right? So you have one keyboard that connect to the input of this one. Then you have the MIDI through, you have also the MIDI output, okay? Which was for sending information from here. But in this particular configuration, you just need the MIDI through. Usually you had MIDI output, MIDI through, and MIDI input, okay? So you have the MIDI through going to the MIDI input, MIDI through going to the MIDI input, MIDI through going to the MIDI input. So how can I say that the key that I'm playing here, that the note that I'm playing here should be for playing the brasses and not for playing the organs, okay? Well, part of the protocol was setting up channels. Like in the way that you in the electrostatic domain, you have channels on your TV, but everything is mixed in the air. It was the same. You said, okay, I want this one to be channel 2, I want this one to be channel 6, I want this one to be channel 8, and I wish this one to be channel 9. So in part of here, when you were starting to play, you say, please send what I'm gonna be playing to channel number 9. So the information is actually going through here, getting into here, but this one says, no, I'm 6. So it's not for me. It's not for me. It's not for me. It's for me. And then I play the note that I was getting in the keyboard. And then you still playing, and then you have another section in the piece. Then you change the channel to channel 2, and now you start to playing piano sounds. Does that make sense? Yes? So that's the reason why the MIDI protocol has channels embedded in the information that you are sending. Later on, the modules start to become more sophisticated, and then you can have multi-channel devices and so on. But that is something that it was happening here. So let's go back to here. Okay. And then that's the part of the MIDI channel. Okay. Let's continue in order to understand what is happening here. Okay. There are a number of MIDI types. At the highest level, MIDI messages, this is important, at the highest level, MIDI messages are classified as being either channel messages or system messages. There are two things that are important. There are two kinds of messages, channel messages or system messages, okay? Channel messages are those which apply to a specific channel, just the thing that I was explaining. And the channel number is included in the status byte for those messages, okay? We will go to that. System messages are not channel specific, and not channel number is indicated in the status byte, okay? It's kind of logic, but we can continue. Channel messages may be further classified as being either channel void messages or mode messages. Channel void messages carry musical performance data, and those messages comprise most of the traffic in a typical MIDI data stream. Channel mode messages affect the way an instrument responds to whatever. MIDI system, this is another pretty nice. MIDI system messages are classified as being system common messages, system real-time messages, or system exclusive messages. We will talk about in later. System common messages are intended for all receivers in the system. System real-time messages are used for synchronization between clock-based components, and system exclusive messages include a manufacturer ID code and are used to transfer any number of data bytes in a format specified by the reference manufacturer. At some point, when they sit in the chair, they're boss of Yamaha, and then the Roland, and all of them together, they say, okay, I agree to send information between you and everybody. But what is going to happen if I develop an instrument and I want to send information to my own instruments? I need the freedom to send information to my proper devices. And then they create in the protocol what is called system exclusive messages. These system exclusive messages, okay, as this text says, they have an identification. So I'm sending a big message, and if I'm a core module, I understand all of that. That is like a subset of that protocol, okay? Now, let's check what we were saying. We have here 1, 2, 3, 4. As you can see here, we have a group of 4 elements, okay? And then we have here 1, 2, 3, 4. How many different values can I express with 4 bits?
$16.
Okay, that means that when I send this message, when I send, for example, let's say how to send a note on, how to send a note on event, okay? According to this documentation, in order to send a note on event, okay, first of all, I have to send 1001. That means note on. Now, these 4 numbers are for the channel. In which channel do you want to send this information? Eduardo, just tell me the channel, any channel that you want to send it.
I don't know. I don't know, teacher.
I mean, I was just asking you to say basically, Pablo, imagine that you have 16 possible channels to send it.
We need to, we're not talking already about the channel of each instrument, right?
We are talking about how is the binary information that is traveling through the cables, and we are building by hand, let's say, one message. I just want you to see how is the message built. In order to do that, we need to create an example. In order to create an example, I was asking you to give me a random number just for the heck of imagining one situation.
Yes, 10 and
10. 10. Now, be careful, because we as humans are thinking channels from 1 to 16, right? But in digital format, this is gonna be from 0 to 15, right? So if you say, Eduardo, channel 10, probably that means that you are talking about the number 9, right? So can you tell me what is decimal 9 in binary? Anybody? Anybody?
Again, I don't understand.
Oh, okay.
I have it here, teacher.
Yes.
It's the decimal 9 in binary is 1001.
1001. Okay, but give me, because maybe I need to do a small description of this. Okay, we already mentioned that in order to send a MIDI message, we are sending informations as groups of 1 byte, which is equal to 8 bits, right? We say that, which means that we have 8 possibilities of saying zeros and ones. We know that the amount of numbers that we can describe here is 256, right? However, we also need to convert, and we will need to be trained in order to convert a binary number into a digital number and a digital number into a binary number. So if I tell you, could you please tell me, how can I describe, okay, how can I put in binary 256, the number 256? If 256 is the maximum number that I can represent with 8 bits,
would have to be
1.
All of them like 1, right?
Yes.
Okay. If I want to say 0, what should I put?
All in zeros.
Okay, we are starting in the easy ones, right? If I want to say 16, what should I put?
4 zeros and 4 ones.
4 zeros and 4 ones. This is 16, right? Just then. If I want to put 17,
Zeros, 0, 0, 1, and zeros.
exactly. Okay. Is everybody understanding what we are doing?
I didn't understand at all. Teacher.
Okay.
Teacher, I have a doubt. Well, I mean, the first bit is not 1. So, for example, 16 must be 0, 0, 0, 1, 0, 0, 0, 0, and 17, 0, 0, 1, 0, 0, 0, 1.
You are all right. You are all right. This is actually 15. This is the number 15. Okay. This is the number 15, and actually this is the number 16. Okay. You are right. Sorry. I get the flow and then. Okay. So, Oscar, we are trained since we are children to count up to 10 because we have 10 fingers, and then we are used to count over 10. So we well know, we have in our brains, since we are really small, that we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And in order to increase that number, pretty much all ways of describing unities in humanity are positional, which means that the same number has different value according to the location. Then you need another column where you have this same symbol. However, in this case, the symbol value 1. And in this case, the same symbol doesn't value 1 anymore. Now values 10, which in Spanish are called las decenas, right? Tenemos aquí unities, decenas, I don't know how to say that, and centenas, no? In the next column, we have centenas, right? Do you see that? Right? We know how to count until whatever next number. So then after you have the 10, then you have the 11, 12, blah, 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 until you have 19. When you have 19, the same things happen. And now you increase the decenas and you reset las unidades. And you go on over and over and over until you reach 99. When you have 99, you need another column in order to describe a bigger number, which now becomes this number, right? Now, in the binary format, you start with 0 again. How many zeros? It doesn't matter because this is the same than this. Un 0 a la izquierda, eres un 0 a la izquierda, yeah, right? Because you don't have a value. So we also know that this is the same than this, right? So in the binary format, you start with zeros and then you start 0, 0, 0, 0, 1. but you only have 2 fingers. You are a very creepy, weird animal, which only has 2 fingers, right? Well, actually 1 finger, well, 2 fingers, right? So because of that, now you need to go to the next column. Really quickly, you need to go to the next column, which that means that now you become 1 and you reset the next one. And then you keep going 0, 0, 0, 1, 1. And again, you reset the columns because you need more columns. 0, 0, 1, 0, 1, right? And then 0, 0, 1, you reset, you need another one here, and then you reset this one. And then you go 0, 0, 1, 1, 1. This is pretty similar to saying 99, right? And then you need another column, 0, 1, 0, 0, 0, which means that this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7, right? And then could you tell me which is the next number? This is 8. Am I all right? Yes. And then this is, oh, this is 9. And then this is 10. You understand what I'm doing? Everybody. 0 questions up to here. 0 questions. No questions at all, right? No questions at all. Okay. Now, if I decide, okay, I'm gonna erase this. I think everything is the same. And then I tell you, okay, could you please convert this number 200 decimal. This is in decimal. Could you tell me what is the binary format of 209? That's like, okay, wait a minute. Yeah, I understand, but now I'm not a machine. How can I convert 209 into binary? Does anybody in this class know the trick how to do it really quickly? Fernanda, can you please share your screen and explain us how to do it?
Yes, give me a minute. Wait, let me get something blank
Google.
in order to.
Who say Google? Yeah, Juan Pedro. Yeah. Of course, you can do it really quickly in Google. And probably we are not going to be doing this by hand all the time. And there is all these computer science calculators in your desktop that you can open. And then you will be able to do that very nicely. But I want you to do it a couple of times just for training, just for understanding. So Fernanda, can you, okay.
Yes. And wait, I'm gonna try to draw.
Mm-hmm.
So it's gonna be a 1, 1, and then wait.
No, but how are you doing it?
Oh, because if I got this right, here is a 1, a 2, a 4, an 8. Wait, well, that's an 8.
Uh-huh.
This one's 16, 32. Oh, this is hard. 32, 64,
Uh-huh.
and 128. So you need to decide which numbers added up together can make the 209, and that's gonna be your position of the ones and zeros.
Oh, what is kind of, I mean, okay, let's continue.
So first, I'm gonna take the highest number in order to reach the 200. And if I add these two, I have 190 something. Let me 192. So in order to reach the 209, I need 17. So which numbers can give me this? 16 and 1. So this is a 0, this is a 0, 0, and 0. So that's how you get 209.
Okay, I think there are another way. That's good. That's good. Yeah, Stefania says good. But I think there is a faster way for doing that. Anybody knows that one? Because I don't remember, to be honest. Let me share my screen.
Yes.
So we will have to do it together. It has to be something like the following. First, let's start with a small number. For example, number 9, which we know that 9 is, what was 9?
Oh, it's 0, 0. No, I don't remember.
It has to be 1001.
Okay, so is
Okay.
9. Can you divide it over 2?
No.
If you divide a 9 over 2, okay, you cannot do that, right? So you put in the 1, okay, because that is what is missing, and then it becomes 4, okay? You understand? If 9 is not divided, you subtract a 1, so it becomes 4, right? And you put 1. Is 4 divided by 2? Yes. And then you put a 2. Is 2 divided by 2? Yes. You put a 2, and then you have 1. Is 1 divided by 2? No, you put 1. Okay. You see that? Well, it's kind of simple. So if we do that, let's see if this works as we are expecting. So what we missing again? Something happened here. Are you here? Are you still there? Okay. So if that is true, then we can start to do the 209. Is 209 divided by 2? No. So 202. And is 202, what is the division of 202? Sorry, 208? 104, right? Is 104 divided by 2? Yes. It's 52, right? Is 52 divided by 2? Yes. Is 20? Is what?
26.
Oh, 26. Is 26 divided by 2? Yes. Is 13? No. Becomes 12. 12 is divided by 2. Yes. Is 6. 6 is divided by 2. Yes. Is 3. 3 is divided by 2. No. Is 1. 2 is divided by 2. Yes. It's 0. Right? Can we check if that is right? So probably we can just.
The last one was not 1, teacher.
So sorry. Let me calculator. I will go to my calculator, and instead of going to the basic mode, I will go to the programming mode. And in my programming mode, I will go to 209, right? And we will see that 209 is 11010001, right? 11010001, which is 2 is divided by y, and then we still this is which one? 3. It was 1, and then it became this is 1. Yeah, that's what you say. Who was speaking? somebody correct me, and yes, this was a 1. And what do we have here? 1, 1, 0, 1, 0, 0, 0, 1. So the number should be read from bottom to top. However, in this case, it was the same because it was palindroma, but this is reading from bottom to top. Okay, so now we have 1, 1, 0, 1, 0, 0, 0, 1. You understand that? You follow that? Yes? Completely sure? Yes, 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 yes. This is important because all the MIDI thing has to do with this in the theoretical part. We will go to the musical part, but it's important for you to understand where is that coming from. Okay? Does that make sense? Yes? No questions at all? Are you sure? No questions at all? Okay, then let's make another exercise. What is the digital number? What is the digital number of 101110111? How can we do this? This is more similar to what Fernanda was saying. Actually, in this case, it's, I think the way that Fernanda is solving the previous example should be applied to this in a more simple way. No, no, no computers, no machine, no machine. Hey, Aldo, no, 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 no calculator, no calculator. Are you done? So first of all, how are you doing it? Just for curiosity, how are you doing this? Estefania, could you explain us how are you doing this, please?
I wish I could, but I'm sure I'm not right. So maybe other person.
Okay.
I guess that I have it, teacher.
Yes, Omar, how are you doing it?
Well, I was doing as well. I knew the same as my partner Fernanda about the base 2 and then just some of the exponentials. And I was well. I have here the result. Can I tell it to you?
Yes, yes, yes.
Well, I think that is 1,721.
Let's see. Is there anybody around there? So let's.
But I started in 1 instead of 2. Starting in 2, I started in 1.
Oh yeah, yeah, yeah. You're right. You're right. Sorry. This one can be 0 or 1. So this is the column of the ones, and then this is the columns of the 2s, of the 4s, of the 8s, of the 16s, of the 32s, of the 64s, of the 128,
28.
254, and
56.
Yeah.
Okay, but teacher, it's not on the other side because you told us that with it starts on the other side. It begins like from bottom to the top.
Oh yeah, in that particular tricky and in that particular way for converting, yes, because it's like a trick. But in this particular case, the number like this number should be understand as, I don't know,
Okay.
as this is, well, no, this is, but this one, this is 6 centenas, 5 decenas, and 2 unities, right? In the same here, this is 1 or 0 unenas, unenas, 1, 0 or 1, this, how can we call these ones? Duenas, forcenas, ectenas, this is eicenas, right? Or something like that. We should think it like that. So what else should we do? Then we just need to add, right?
Yes, then there is 747, the result, I think, because
Okay, so it's,
I do it on the other side, on both sides, but it's not right, the other one.
I see. Do we have 500 docenas? Yes. Do we have 250 cenas? No. Do we have 128 enas? Yes. Do we have 64 enas? Yes. Do we have 32 cenas? Yes. Do we have 16 cenas? No. Do we have octenas? Yes. Do we have cuatrenas? No. Do we have docenas? Yes. Do we have unenas? Yes. So we just need to add, right? Ah, this is ugly. Can you help me? This is 10. This is 20, 20, 24, 26, and 27, as far as I see, and I have a 1. So this is 10, 10, 13, and we have a 1. Ah, it's very hard to add in English. 6 and 1, 7. Is this, is this correct?
Yes, teacher.
Is that the number that you get, Omar?
I get both the one that I told you before and 747 because I did it in both ways. But yes, it's
no, but this is the right one. Okay. And in these kinds of things, always trust Omar. Don't trust me. Always trust Omar. Okay. So is this okay? Did you reach this number? Did you reach this number or you didn't do it? Because if you didn't do it, you have another chance. Now, please give me the number of this one. 1100110010. Please give me the digital value, the digital representation of this number, please. Please do it, Eduardo Lagunes. Are you doing it, Pablo, Oscar?
Yeah, sure, I'm trying.
Mm-hmm.
I think I have it.
Just give it a few seconds so everybody can finish.
I think I got it too.
Okay, just wait a second. Aldo, are you done? Please raise your hand as soon as you are done with the calculation, please. Oh, please your digital hand, Aldo. Otherwise, it's gonna be. Estefania, please raise your hand. No calculator, please. No calculator. Fernanda, you done? Okay, 3 people missing, 3 people missing. Let's give another 15 seconds. Come on, come on, come on. Pablo, Fernanda, Oscar, Eduardo. Gone. Oscar, Pablo, Eduardo. Okay, Oscar, Eduardo. Good, Oscar. Okay, done. Okay. Can you tell me the number?
818.
Yes, everybody, 819. Eduardo, did you miss it? No, yes, good. Everybody? Yeah, okay. You can always say.
I think so.
Speed or precision, professor. Okay, so that's good. Okay, so we have, you understand now how can convert from here to here. Now, imagine that I want you, okay, okay, let me erase this. Okay, another little detail. Okay, well, what time is it? It is 5:32. I'm gonna make a pause of 12 minutes, okay? Just because it's good. So see you here at 5:40, 5:50. Is that a lot? How much is 15 minutes? 17:45. Okay, 17:45. See you here at 17:45. Okay, please remind me to record once that we are back, because I'm gonna pause it. Okay. Hello, everybody. Hello, everybody. I don't know. Okay, come on, everybody. Okay, could you please turn on your cameras? Okay, okay. Exactly, Ricardo, like that. Come on, everybody. Okay, so Aldo, Oscar. Okay, everybody's here. Yes. Okay, so let's go back, and maybe we should round all this topic about MIDI. Now, so we have, oh, I'm not sharing my screen, do I? No. Okay. Now that I'm sharing my screen, okay, we should round and continue with another topic that we cannot avoid, which is the other way of counting in computer science that is very common, which is the hexadecimal numbers. Okay. Have you ever made any exercise converting from decimal to hexadecimal and so on? No, no, Eduardo. Okay. So yes, no, no, Santiago, no, Fernanda. Yeah, I think Fernanda that we did it. As far as I remember, we did a couple of things at the class. Maybe yes, maybe not. Okay, so which is the point is this one. Okay, imagine that we are from another planet and we have 16 fingers. Instead of 10 fingers, we have more symbols for representing, values before going to the new column. So if we have a 0 in this is gonna be binary, okay, which we are gonna describe as 0x. So each time that you see a number starting with 0x, oh no, that is not true. This is hexadecimal. It's the binary. I think it is a B of binary. And then we have decimal that has nothing. And then we have hexadecimal that starts with a pound symbol. Okay. Oh, if this is pound symbol, yeah, 0x I think is hexadecimal. Okay, so we have
Professor,
0. Yes.
I don't know if I'm the only one, but I think the top part in which your drawing is chopped. I can see whatever you're writing.
Can you see here?
Yes, yes, I can see.
Okay, so this is the column of the binary, and this is the column of the decimal, and this is the column
Okay.
of the hexadecimal numbers that start with a
Thank you.
pound. And this one, I think, start with a 0x for describing binary. Okay, so in decimal, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And if we need another one, we go to 10, 11, 12, 13, 14, 15, 16, 17, and 18, and 19, for example. In decimal, well, in binary, we already know it. I'm not going to do it again, but we know that this was 0, and this is 1, and this is 1, 0, and this is 1, 1, and this is 1, 0, 0, 1, 0, 1. You understand that from the previous part of the class. Now, let's go to the hexadecimal part. The hexadecimal part is pretty cool because then you have 16 fingers, okay? So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is this one, 10, okay? Oh, no, sorry. And then we have 9, okay? And then we have another symbol before going to the new column, okay? Which symbol is that one?
A.
Exactly. So we can keep going with just one column. A, B, C, D. So A is 10, 11 is B, 12 is C, 13 is D, 14 is E, F is 15, and now we are running out of symbols, okay? So what is the next number?
Ace.
10.
Wait.
Well, it's not 10, but it is 1, 0, okay? So 1, 0 in hexadecimal format is not 10, is 16, right? You understand, Oscar?
I'm trying.
Okay, we keep going. Then this is 16, this is 17, okay? And then this is 17, 18, 19, 20, 21, 22, 23, 24, 25, and now how can we do 26?
One A.
Exactly, 26, 27, 28, 20, 29, right? 29, 29, 30, 30, and 31. And how can we do 32?
Two zero.
Exactly, 2, 0, okay? You understand that? Now, instead, because it's a mess to think like that, let's differentiate by adding just a pound. So you know that this number is not 20, but that this number is 32, okay? Because now it's the same thing. Instead of having unidades, decenas, centenas, and milenas, or how do you say that? Decenas de centenas, or how can you say, well, los miles, right? Instead of having that, This is our traditional way of knowing. When we have in decimal number, a number like this one, 8, 2, 1, we know that we have 8 centenas, 2 decenas, and 1 unidades. When we are in binary, 1, 0, 0, 1, we know that here we have las buenas, as we were saying, right? Aquí tenemos las docenas, as we were saying, right? Aquí tenemos las cuatroenas y aquí tenemos las octenas. You understand that? This is just what we were doing before the pause. And now in the hexadecimal format, we have las unidades, right? And now these are not decenas, but these are las dieciséisenas, okay? Dieciséisenas, okay? And how much is 16 times 16?
$256.
256, which means that here in the hexadecimal, we have las buenas, las dieciséisenas, or I'm going to do it here. Las buenas, las dieciséisenas, and here we have las 256. Okay? So in hexadecimal format, the number 1, 1, F, for example, it's gonna be 256 más 16 plus F, where F is 15. Okay? So this is, I think it was this number, as far as I can see. Okay? You understand that? Oscar? Are you sure? Completely sure?
I'm going slowly, but I'm trying.
Okay. So, okay. Now what happens if we have this number? 3, 2, 0. In hexadecimal format, the number 320. What is that number in decimal format? Can you tell me, please, what is the number 320 in hexadecimal? The hexadecimal 320, what is the real value in decimal form?
It's 900.
Wow, I don't know. I don't know. Okay, one person is saying that it's 900, maybe. I don't know. But how can we get it? If we in the regular decimal, when we have the number, I don't know, when we have the number 320 in decimal format, that means that you have 0 unidades. Sorry, I don't know how to say that in English. And that you have dos decenas, because this is the order of the tens, okay? And 3 centenas. So you have 300 más 20 plus 0, because you have 3 centenas, right? That means that if I'm asking you what is the value 320 in hexadecimal, that means that you have 256. That means 256 times 3 plus, well, I'm going to do it here, 256 times 3 plus 16 por 2, 16 216 cenas, which is 32, right? Plus 32. And how much is 256 times 3?
768 plus 32, it's 800, I guess.
No, so we have two different values. Who is the good one?
It's 800.
Okay. Yeah, because it's 763 times 32. Okay, that's it. No? It's 800. You understand that? Now, why is that? Why is so common to represent numbers in hexadecimal format? Because it's very nice. Look at this number. The number F0, okay? If you have the number FF0 in hexadecimal format, okay? You can split it very easily into binary. Why? Because you cut here, and then you have an F. F is alone. How much is F alone? In terms of values? In terms of
16?
No, F is
15.
15, right? Remember that there's a problem, is that we have the way of representing 0. We have the way of representing 0, but how many different values do you have in order to represent things? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when you want to represent the number 10, it's when you need a number, a new number, a new column. Well, I don't know if this explained, but yes, when you have F is 15. So this alone is 15. And how do you represent 15 in binary?
1, 1, 1, 1.
1, 1, 1, 1. And another 15, 1, 1, 1, 1. And 0, 0. So look how easy it is to convert, okay, from hexadecimal to binary. And the same, this tricky number, 1011001100010 1010. If I would ask you to give me this number, this binary number, into digital, you are gonna suffer a lot, right? Why? Because you will have to see, oh, these are the ones, these are the two, these are the fours, these are the eights, these are the what, the 16s, and so on, right? But if you split by pairs, now just give me this number, which is binary, in hexadecimal format.
B.
This is B. Oh, okay. I trust you. How do you know it's B?
Because it's like, well, I know that 10, well, for example, 1010, it's 10, so it's equal to A.
Okay.
So 1011 is B.
I trust you. How much? And this number?
3.
Okay. And this number?
2.
Okay. And this number?
A.
Okay. So look how fast we convert from binary to hexadecimal, right? You see how nicely we can jump between groups of 4 binary values and 1 hexadecimal character? Yes, you see that? And the same, how easy is to jump from 8A1 from a hexadecimal number, how fast we can jump from here to a binary. If this is 1, is 0, 0, 0, 1. If this is A, is 10, 1, 0, 1, 0. And if this is 8, is 0, I guess is 1, 0, 0. Am I right?
I think, oh yeah, you're right.
Oh no, it's 1, 0. right?
Yes.
Okay.
Yes.
So 100010100000001 is 800, no, 881. Nice, right? That's why it's so common to see hexadecimal numbers in a lot of code, in a lot of codings, because that way you know that you are talking about groups of 8, oh, well, not 8, yeah, 1 byte, groups of bytes. Okay, now we can go back. Now we can go back to our MIDI formats. Okay, to our MIDI format. Now we can understand that in order to send the message, please play C piano. In order to send that information through a cable, please start to play middle C in the channel 1. Okay, what we are actually sending is the number. Sorry. In order to send that, okay, okay, we have to see from this list which is the command note on. The command note on start with the values 1, 0, 0, 1. Okay, so 1, 0, 0, 1. That means MIDI note on. Then we have 4 values for setting up the channel, which now Oscar, I think we can, well, Oscar and everybody, right? Now is the channel. And an hour ago, somebody says a number for sending a hypothetical situation, which was channel what?
And
Oh, yeah, it was channel 10. Now we can write channel 10. What is the channel 10?
1010.
1010. Okay. That makes the first part of the message note on. And now here comes the second part, data bytes. This message is sent when a note is depressed. And how should we know it? Key is the keynote number, okay? This part is the keynote number. And then the second part is the velocity or is the volume, right? Now be careful with this. Pay attention to this. How many values do we have for representing the volumes in MIDI? How many different values can we use for setting up the volume or the note or the whatever?
Is it from 0 to 127?
Exactly. Which in total, how many values do we have?
128.
128. How many bits encompass 100 and 128 values? How many bits?
8.
No, 8 bits. We already saw
4.
that. No.
7.
Yeah, but it's not tombola. 4 allows you to have 16 values. 8 allows you to have 256 values. And 7 allows you to have 128 values. Now, how comes? Why 7 bits for representing any parameter, musical parameter, if we are talking about groups of 8 bytes? Because the first one has to be a 0, okay? The protocol says that the first one has to be the 0, okay? And we will see why the 0 in a moment. So that means that I'm going to start to write it again one more time here. So we were saying 1 0 0 1 1 0 1 0, and then what what note do you want to send? Tell me a note that you want to send. Which key of the piano do you want to press?
G.
Which one?
G.
G. Which G?
G4.
Okay, let's go to see the G4. Okay, this is the piano. Well, this is a hypothetical piano. No, actually, this is a real piano, right? Because this is starting in MIDI note number 21. The piano does not have 127 keys, right? A regular piano has how many keys? How many keys has a
88.
piano? 88. Which is the piano that has more than 88 keys? The Bolzendorfer piano. It is a huge piano that has 4 more keys in the left. And when Claude Debussy, the French composer, saw that piano, he decided to compose a piece called La Catedral Sumergida. Okay, so if you're a piano player, you will see a score that is very weird because it has some low keys. And it's a beautiful piece, which you cannot play unless you have a Bolzendorfer piano, right? But that is, you should just check for that. You know Claude Debussy, right? Claude Debussy, the French composer from the what is the from the el periodo impresionista of music, right? Okay, so but a regular piano starts with the key number MIDI number 21, right? So if you want to play the middle C, you were saying if this is middle C, you want to play the key number G4, this one, right? Which is which one?
66, right?
No,
Oh, 65.
65, okay? So it's 65. So if it's 65, okay, no, 65, right? So we need to decode number 65 in binary. 65 in binary. Can you tell me what number is 65 in binary? Well, we already know it, right? We have a 1 and we divide this into 32, right?
Yes.
0,
Yes.
16, 0, 8, 0, 4, 0, 2. What else?
1, right?
No, 2 is divided by 2.
Oh, no, yeah, 0. Yeah.
0, and then
1.
1.
and 1 becomes 1, right? Am I right?
Yeah.
Yes.
And then the number is 1, 0, 0, 0, 0, 0, 1. So now we can put 1, 0, 0, 0, 1, 2, 3, 4, 5, 6, right?
Yes.
And now comes the second part of the message, which is 0 again, 0 again, and then the volume. Do you want to play that C, that G in soft, really soft, or you want fortissimo? What do you want for that G? Or mezzo forte? Mezzo forte, forte, fortissimo. You are the composers, guys.
Fortissimo.
Fortissimo, okay, fortissimo. Okay, so what is the more highest volume that you can send?
127.
Yes, which is which binary number?
0, 1, 1, 1, 1, 1, 1, 1.
Say 7 ones, right? Okay, congratulations. You have built the first MIDI message of your life, okay? If you would have a battery, if you go to the pharmacy, me da una pila de 9 volts, por favor. Yeah, and then you have it. And then you get a resistor for decreasing the volume to 5 volts. And then you plug the cables into the proper pins of your MIDI. And you have the ability to play of moving your hands at, where was it? At 32, what was the speed? 31,000.
250 era. 31,250.
Yeah, a 31,250. If you can move your hands at that speed, and then you put current, and then you open it, and then you keep it, and then you do what I did at the beginning of the class. Tit, 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 tit. If you do that, you will make your keyboard to sound G at 40. Okay, so really fast. It seems really fast, but you will see at the beginning that it becomes slow at some point. But you have a MIDI message that you will have to understand. Now, why did they decide to have this as a 7 bits resolution protocol instead of 8 bits? Okay, because when you get the message, okay, if I start to say, okay, sorry, we're gonna, did you know the game that children plays that says, come on, 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 or that says, monja, 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 mon. Am I saying monja, the people that believes in the church? Or am I saying jamon, the thing that go inside a rica torta? Okay? What am I saying? You don't know, right? If you leave the room and I start to say, come on, 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 and you enter the room, you won't be able to know if I'm saying monja or I'm saying jamon, right? Unless I do this, monja, 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 okay? Or I say jamon, 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 jamon. Then you will notice, because you need a value. You need a value that says, when are you starting to say the information? Because the MIDI note has all these duration, and some of them could be longer, okay? Some of them could be longer, okay? You need a way for saying, and then start to say the message that you want to say, and then saying a new message, So when you enter the room at the beginning, if you enter the room and I'm not saying you know that you are in the middle of a message until you get the and then you synchronize, right? That is what is happening in this particular case. I'm gonna copy the value again here because can you see if I write here? 1 0 0
Yes.
1 1. What was 0 1 0 0 1 2 3 4 5? Oh, 1 0 1 2 3 4 5 7. That's the full message, right? And then you subdivide these in groups, and then you subdivide these, okay? And then in this particular case, you have a 1, 1, 2, 3, 4, 5, 6, 7, and 8. And then 1, 2, 3, 4, 5, 6, 7, and 8. And then another 8, okay? The only way for knowing that the message starts here, and then you have A, B, or I mean, message 1, 2, and 3, in the same way that Monja, M-O-N, right? The only way for knowing that is that this is the one, the message that has a 1 on it, right? And the difference of this one that has a 0, so that this is not the beginning of the message. This one has a 0. This is not the beginning of the message. And then you know that the next one we're going to start with a 1, right? So now let's go forward. Let's go to understand this message if you see it in binary. If you see it in binary, okay, you see and you wait. Where is the 1? Here is the 1, okay? That means that this message is the one that is saying what kind of message we have, right? Now we split this into groups of 4. We split this into group of 4. Then we go to the beginning of the message, okay? And we know that the message 1001 is MIDI on. That means play a note. Then we go to the second part of the first message. And then we encompass. This is the channel. We know that this is channel 10. Send a note on channel 10. Then we go to the second group and we get the value, okay? This value, we already know, we do the transformation, and we know that this is 65 because because the message is note on, then we know that we should understand this as a G4, okay? And then we go to the third part. Because we know that this is note on, then we know that this should be understood as volume, okay? And then we go to the value, and we know that this is 127. That means play a note on channel 10 G4 very high, okay? You understand that? Okay, so let's go back to our specification. In the same way that we have note on, we have note off. I don't know how many times has happened to you. Now that everything is in the digital computer, inside the computer, that information is still be traveling, but it is traveling now in a digital format, not in an electrical signal, as it was in the previous times. In my job, when I was playing music, it used to be like, when you unplug the cable at some point, you have the sound playing, and then it never stops. That's because you never got the message note off. Sometimes the message gets lost. That could happen also in Ableton Live. Well, not in Ableton because they spend time coding, but sometimes it happens that you press stop at the beginning, in the middle of a note, and then it doesn't stop, okay? Because the message is compromised of 2 things. Note on, when you want the sound to start, and then a message for note off when you want to stop it, okay? So in order to stop a sound, you send the message 1000 for note off. This one that we saw for note on, okay? This is pretty nice. This one, we're gonna skip this one for a second, okay? We're gonna skip this one for a second. But this one is for sending some polyphonic key pressure, okay? Okay, this is, well, no, actually we can see it at this time. At that moment in time, the keyboard was the only way for doing fancy things. Now you have another interfaces for doing that. And pretty much now people is starting to stopping to play instruments. You don't need to play an instrument to make sound, to make music. 20 years ago, if you want to make music, you need to play an instrument. Now you maybe use everything in Ableton Live and you put the arpeggiator and then you put things and you don't need to play so much instruments. But in that time, the keyboard was the way for doing expressive music. So the aftertouch was something that happens pretty cool. I cannot move my, yeah, I think I can move my keyboard. Can you see my key? Okay, this is a keyboard from the 80s. And it has something pretty cool because when you press it, you start to produce the sound. And if I aftertouch and if I press a little bit more harder, you have a, okay? You can, actually we can hear it if you don't, if you want, okay? It was kind of expensive to do that because you need two sensors, two electrical sensors inside the keyboard. You need, you see, one that I press, and I'm gonna press. Then what happens when I apply pressure to the key? Okay, that was the message polyphonic key pressure. Okay, and then you have another ones which are interesting. For example, this is important. Control change, because control change is not applied anymore to a key. All of these ones has as a second parameter the key and the volume, the key and the volume, the key and the pressure. In this particular control change, now you don't have the key, okay? This is treated in another way. This is treated to which control number and the value of the control number, okay? Which control number is the first message, which control number, and the value of the number. And usually these apply to all the channel, okay? This was something for changing the volume of the channel, the panning of the channel, the attack of the sampler. And so let's go and check the list of different channels that happens to be in that period of time, okay? For example, a foot controller, if you want to mimic when you press the key of the piano and you start to have sustain, that was one value, which was, I think, value number 4, okay? Then you have also panning, for example. If you want to change the stereophonic scene, you have number 10 in decimal, okay? If you want to send, which are other that are common, as you can see, all of these ones were undefined. If your synthesizer has it, you can use it, but you can send also breath for the flutes and things like that. If you want to, all of these ones, pretty much many of them undefined, effects, sound vibration, timbre. That doesn't mean that the sound will change. Your device should recognize that message. But okay, can you please build the binary message? Pay attention. Okay, exercise for the next 5 minutes. Please, okay, send a control change message on channel number 3, okay? And change the panning completely to the left, okay? 0 was left and 127 was completely right. Actually not, actually put it in the center. Change the panning of channel 3 to the center, okay? Please build the message, the binary message for changing channel 3 to the center of the panning, okay? You have 3 minutes. I'm gonna send you this link, by the way, because you will need to go back and forth into that page, okay?
Sorry, teacher, you said to change it from the left to the center, or how? You are mute.
Are you done? Please raise your hand while you are finishing, so I can know. Come on, raise your hand when you are done, please. Or you have questions? Okay, no. Two. Santiago, you have questions? Okay. Okay, so
Yes, I don't know if I have like the correct number.
okay. Oh, but you try to do the exercise, right? Okay. Raise your hand if you have done the exercise or if you get stuck and you won't be able to finish the exercise. Axel, Oscar, Pablo, and Luis.
I'm stuck, teacher.
Okay, so raise your hand. Oscar. Okay. Okay, I think we can continue then. Which, how can I, as far as I can see, I can. Okay, that's it. Okay, Ricardo, can you explain us what you did? I'm going to stop sharing. If you want to share your screen, please.
Okay. Well, first of all, I took the first part of the message with the control change. That was 1011.
Okay.
Then I took the channel number that it was number 3. That would be no 0011.
Mm-hmm.
And this was the first part of the message. Then I looked for the serial number of panning that was 000 and another 0 1010.
That was panning, right?
Yes, this was for
Okay.
panning, and since you asked us to leave it on the center, the value that I took was 64, and that would be 0 1 0 0 and then another 4 zeros.
Excellent. So we have control message, the beginning of the first 4 beats.
Yes.
Then channel 3, the second part.
Mm-hmm.
Then the saying that it's going to be panning, which is all of that message. Good. And then the value, which is that message. Yeah, everybody in the group has that value. Yes, yes, yes. Okay, so moment of questions. Axel, where did you get stuck?
In the panning code,
Oh,
in the middle of the old code, in the panning code, I think it was.
yeah. Okay, and that's because you didn't because of what? I'm gonna get the screen, Ricardo.
Yes.
Just if you go here, okay, to the link that we sent, and then you go here, you will see that the panning, okay, was this particular value. Is the value number 10 in decimal, the value 08 in hexadecimal, which in binary is the 00001010. Okay?
Oh, okay, okay. It's clear now. Thank
Are
you.
you sure? Yes, yes,
Yeah,
yes, yes.
yeah.
Okay, now just for finishing the class, I'm gonna give you, I want you to tell me, okay, what is this value? Okay, what is this value? Okay, 1110, okay, 0001. I'm gonna repeat it again. 1110, 0001, and then 1 all ones. Okay, 16 ones. 1110, 0001, and no. I'm sorry, not 16 ones. 0 and 7 ones, 0 and 7 ones. I'm going to write it in the chat, which is 1110, 0001, 0, 1, 2, 3, 4, 5, 6, 7, 1, 1, 2, 3, 4, 5, 6, 7. That's it. Okay. Okay. I want you. Yeah. And just 1 minute. Okay. I'm not a good professor. I'm doing something that is not nice because I'm asking you to say something that you don't know. Okay, but I mean I mean bad, ugly professor. But I want you to infer what's going to happen in this case. Okay. In the meantime, I will go to see if you can hear this. Okay, because I want to show you something. Fernanda, you have the solution?
I think so.
Okay, just give us another minute for the rest of the group.
Sure.
Okay, Eduardo Lagunes, done. One, two, three, four. Five. Six. Seven. Okay. Axel, Oscar. Pablo, Pedro, Juan Pedro, Pablo Escamilla. Juan Pedro, do you have it? Okay, that's good. Okay, so Fernanda, can you explain us what is that message?
Yes, from what I decipher, it's a pitch change
Okay.
in channel 1, and the function is polymode at the highest potential.
Polymode?
Yeah, that's what I got. I don't know if it's right, but
Okay. Anybody else? Let's study. Let's check first. It is starting with what?
a pitch change.
Pitch change. You mean pitch will change, right?
Yeah, that's right.
Okay, so no, it's okay. So we have the pitch will change, right? 1110. You say channel number 1, right, Fernanda?
Yes.
Oh, you mean number 1 is starting computer speaking or human speaking?
Computer speaking.
Okay, human speaking.
Oh, wait, is that a trick question? Because I don't know.
Usually musicians never say, hey, Poland channel 0. It was from 1 to 16 instead of 0 to 15, right?
Oh yeah, you're right.
Yeah, so we just have to decide. Yes, is channel 1 starting in 0 or channel 2 starting in 1? Okay, but in some programs you didn't see the channel 0. You always was checking from 1 to 16. But yeah, it's channel number 1, right?
Yeah.
And then what else?
I got the polymode.
Polymode. You went oh, I guess you went, did you go down to check it down?
Yeah.
Oh, that's interesting. Yeah, that was the thing that I was saying, that I'm a bad person. Okay. Why? Anybody else with another result or another conclusion after reading this?
Yes, me.
Yes, can you?
I have pitch will change channel 1 and no pitch change in the center.
Not pitch change, no pitch in the center. Okay, now pitch change. Okay, now this is the point. Okay.
Well, I got a different interpretation, I guess.
Yes, which is which one?
I think that it's a pitch will change on channel 1, and it's all the way to the top, which will be represented as a whole tone, the change of the pitch.
Okay, that is a nice thing that we were talking about. Okay, so this particular message is made of two.
Screen reader on.
No,
Screen reader off. Screen reader settings reloaded. Screen reader off.
I get confused in my. Wow, are you there? Yes. Can you see my screen? I guess yes. Yeah. Oh, okay, that's it. Okay. The point is this one. How many levels of resolution do you have in order to see a difference in volume? We as humans, we don't have, maybe that is a question. If I put an audio value in 0, what is happening, Stefan? Oh, your dog. Okay. When you have, can you hear the difference in volume? if you have a channel, if you have your volume in 62 and then you move it to 63, it is a tricky question. But if I change the volume of my channel and I have a resolution from 128 different values, and if I move the slider just one value from 63 to 64, will you be able to hear the difference in volume? In a regular conditions, no, right? It's gonna be hard. It's gonna be hard. Well, it depends. What is your maximum volume? If you are in a concert hall where you can generate 120 dBs, an extremely high volume, an extremely low volume, maybe you are going to start to hear it. But in regular conditions, you won't be hearing the difference, right? That's why 7 bits of resolution is enough for setting up the volume. And the panning, how many different positions in the space can you put, right? If you have, if this is your sound, and this is your speaker left, this is your speaker right, and this is value 64, right? This is value 0, this is value 127, right? And this is value 64. If I move the panning and then I put it in 65, probably you won't hear it, okay? So again, 127 values of resolution is enough for setting a decent position in the panning. You understand what I'm saying, right? However, 127 values for having the feeling of a glissando, okay? For having the feeling of having an entire, are you listening this guitar that is, yeah? Having 127 values for setting up the different frequencies. If, well, right now I'm just uploading for one tone. But if I decide to change the pitch to be an octave long, would be not enough resolution. So some MIDI values require more than 127 values. So how can you solve that? Well, you set 2 words, 2 elements for setting up the values. So instead of having 127 values, you will have 14 bits of resolution. The pitch wheel is measured by a 14-bit resolution where you have the least significant values and the most significant values, okay? So this message is a message that is all the two values. So you have 110, 1110, and 0001. This is pitch, this is channel, and then you have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You will add these 2 parameters. You will have this, okay, as a one unique value that is made of 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Am I explaining properly what I'm saying? It's a parameter that is not made of maybe pitch and volume. This is made pitch with a resolution of 127 possibilities and volume with 127 possibilities, or panning, 127 possible control change programs and 127 possible values. In this particular case, is made only of one unique meaning of 14 bits. How much is 14 bits? I don't know why 14 bits is Well, for bits is 128 times 128. So it's going to be very easy if I go to a calculator, calculator, and then I just multiply 128 times 128. Okay, 1,600,384 possible values. Okay, so this is with the value 16. What was it? 384, 16, 384, right? Full to the top, all way to the top at this resolution. Yes? Does that make sense? Or not? Ricardo, I don't see your face. Yes? Okay, Fernanda? Why so?
I'm confused about adding both groups, the pitch and the volume.
Mm-hmm.
Can that
well,
be
no,
done
be careful. It's not the pitch and the volume. Okay. It's this value and this value. Okay. When I mean adding is that you make a longer number. Okay.
Okay.
How can we say this? Just put it in this way. For some of the messages, message, channel, right? First element 1, and then second element 2. This is channel, and this is kind. Let's think it like that. Kind, 16 possible values. Channel, 16 possible values, because this is just one word, right? And then 127 resolutions for one thing and 127 resolutions for another thing, right? Okay. Which in case of notes is note, channel, pitch, and volume. Which for a control change is control change, channel, which control change, which one, which control change, and then value of the control change, right? You understand that, right? And in this particular one, in the pitch wheel change is pitch wheel, channel, okay? And instead of having 127 for one thing and 127 for another thing, you have all these two together, all these 17 bits, okay, for the resolution of the value with a lot of resolution.
Okay.
Yes, because here you have 7 bits of resolution, 7 bits of resolution, 7 bits for the volume, 7 bits for the pitch, 7 bits for the value, 7 bits for the which. And in this particular case, you have at the end 14 bits for the resolution. Okay. And 14 bits give you way more resolution than 7 bits. With 7 bits, you can only represent 128 values. With 14 bits, you can represent 16,384 values, right?
Okay.
So you have more resolution. Why do you need more resolution? Because our ear can recognize changes in frequency very easily. Okay?
Oh, okay. Yes.
Okay. So with this, the class is over. Okay. This we are not going to have a lot of classes as just like this one, but it's very important to understand where is everything coming from in the sense of this protocol that has been with us for 25 years and Ableton Live and all of the programs uses that all the time, right? All the time is still a very active protocol. Okay. Does that make sense?
Yes.
Okay, so we do not have any assignment for next week. Just we are warming up. Okay, we're warming up. That doesn't mean that the things are going to be like that all the time. We're going to start to have assignments regular basis, but not on this case. Just if you have questions, just Google in any part, just Google MIDI protocol. Probably if you search in YouTube, MIDI protocol, somebody is also going to be explaining that, right? And it's going to be important. What we're going to start in next class is coding MIDI parameters. And for that, we will have to do it. I was thinking how to do it, and I think we are going to do it in Super Collider, okay? Because it's going to be nice to make something that in Super Collider, we're going to start to send either to your keyboard, either to Ableton Live, or either to any virtual instrument that you have, okay? That's what we're going to see, because that can help you to understand what is happening on the MIDI parameters, right? So that's all for today, guys. I hope that you had a nice class. The recording is going to be uploaded as soon as it is rendered. We don't have a WhatsApp group as we did in the previous class, right? Can anybody be kind enough to create a group that you are? We still have the other group, right?
Maybe, I don't know. I'm not sure.
No, maybe not. Because I don't have your phones. Well, for this week, we will do it over email. If you have any question, just send me an email, right? And we are going to try to have something in Telegram or WhatsApp just for fast things. But in the meantime, that's it. Okay? Okay. See you next class.
Thank you, teacher.
Bye.
User.
Thank you.
Thank
See you.
you.
Teacher. Bye bye.
Thank you. Thank you.